So first of all, this is the webinar that kind of finalizes our series of Jumpstart Your DFIR Journey. We wanted to get into what is DFIR, what we're doing, what we need to know, forensics, and now, I just think this is a really cool final kind of session that we can do here, talking about the tools and the techniques and the environments that you could set up in order to make your lives easier, because that's something that's not too often discussed, I think. And so I want to show you a few cool things here. Okay, quick overview, right? For those who have been around before, that you guys know what we are talking about here. For those who are new, this is what we have been working on. So basically, we want to get everybody up to speed on DFIR. And this was like called Jumpstart Your DFIR Journey, which starts basic. So you got the fundamentals, but still a lot of practical kind of knowledge that you need to know in the field. We started with discussing even, threat landscape. What are the threats, the cyber trends out there that we need to be aware of based on, latest reports that we covered. And then what does it mean to even apply digital forensics, incident response? What are the skills you need? Followed by last week's session where we had a threat example and a case study, and then looked into important forensics concepts and artifacts, right? The most important part is when you perform DFIR, knowing how to analyze and what to analyze, what artifacts and where to look for it. So that was part of last week's session. And this week, we're going to look at how to do these things in terms of what are the tools and the applications that we typically see in environments and DFIR environments, from training labs. Like I'm sure there's a lot of students here around that have been working on training labs, but also we have professionals that have do this on a daily basis. So I hope, and I'm sure there's something around here for every one of you. So if you are actually, if you're kind of new, or if you're experienced, let's do a quick poll in the chat here. So are you currently in a DFIR related role? Yes or no? Just type in the chat, yes or no. Do you currently work in DFIR, or do you not? Do you work in something else, or are you just a student? Perfect mix, lots of yeses, but also a few no's. Yeah. Yes, no. So, wow, this is more yeses than I expected. So DFIR related people here, awesome. SOC tier 3 team leads, kind of, I 100% agree. Tier 3 probably is DFIR, touching DFIR. Awesome. A few students, some no's, but a lot of IRs, lots of yeses too. Okay, I hope this is there's a lot of good stuff for you, how you can improve from there. Trying to get more hands-on, that's always a good one. Yeah. I know not every environment is easy to get into these things hands-on and to see all the cool stuff. And let me maybe say just this, like the problem for our job is that we as cybersecurity professionals, especially on the incident response and forensic side, we get paid to prevent and detect things before, bad things before they happen, right? So we don't get to see the cool stuff in an ideal world, because great for the company, right? If they don't get hacked, if nothing get compromised, if we're doing a great job, great for them. But we also are probably not building out a lot of great experience unless you're consulting, jumping from case to case. So, it's a catch-22. So that's why we need to talk about training a lot. And I think this is a pretty good thing to keep in mind, right? We are here to protect the company, the organization, to limit the damage, but also you don't get to see all the cool stuff usually if you are, in-house, especially in an organization where not much is happening. And when it happens, all of a sudden, things blow up, and you need to be prepared, which is hard. So that's what this is for. Let's continue this journey. And so talking about the tools today, why is it important to understand what the options are and then improve your DFIR tools and processes? So it helps to effectively respond to the cybersecurity incidents, and you can drastically minimize the impact if you know what you do, right? If you have locked in processes, if you have the tools ready to go. It ensures that your lab basically is ready to go, so that you can conduct swift investigations using the right tools for the right job. And there are so many tools out there. There's tiny, small, quick open source scripts. There's enterprise applications, everything along the line. So you need to pick what you need for a specific case. And those can be, scenarios can be broadly, like widely different. And then also we need to, have consistent processes so that you can accelerate those investigations and reduce the manual labor and avoid human error, right? Because the more you can automate, the more you can actually streamline, the less human interaction you need, the less labor intense, the more time wasting you do, and also the less chance for human error because people need to conduct forensic investigations. There's a manual part of this for the most part, and the more you can avoid that, the more you can streamline those processes and avoid human error. So that's also, do you have a team? Probably everybody has different strengths and weaknesses, so it's important to be consistent to have solid outcomes. So today, specifically, what we're going to be talking about is forensic workstations, the basic tools and things you might want to be aware of, enterprise DFIR tools, so what you see in enterprise environments typically, and how you can basically take that to the next level, automate, scale, getting more advanced. And then at the end, we're going to cover Q&As again. As always, please use the Q&A in the Discord, and I'll cover all these questions later. And also I'll check frequently in the Discord channel as well. Now, a few of you have seen actually something we put out yesterday in Discord as well as on LinkedIn. We wanted to know people's confidence level in terms of technologies when it comes to the data collection, the forensic analysis, SIEM, EDR, NDR tools, or incident response automation. And it's really cool. On the left, you can see our Discord current status of the Discord polls. On the right, you can see a LinkedIn poll. It is very much along the lines of same kind of trends here. So it seems like most of you are still not too comfortable in terms of forensic analysis and the tools to be used, which is great. This is our specialty area here, so we can definitely, we'll be looking into that, and we have some resources for that as well. But everything else is also part of it, right? Especially in DFIR. So it all starts with data collections. And I like that it's at least of concern, because people underestimate that part a lot, I feel like. So we can't just, prepare enough to be ready for data collection. Forensic analysis, of course, we need to know about. I'm surprised most people don't feel overwhelmed or too confused or too challenged by SIEM, EDR, NDR tools. That's great, because that's what you will probably see all day and out in your enterprise environments. And incident response automation, that's more the advanced topics, and we'll talk about that today. I'm glad there's lots of people that are interested about that as well. But I think it's great. The trends are the same across different platforms. We have a good sample rate. So 150 people almost altogether. So I think this is a pretty meaningful one. And so let's kick it off. Building your forensic workstation. Not a quick question for the chat. Who has taken the practical Windows forensics course, no matter on which platform? Yes or no? Just answer yes or no, because I feel like a lot of people are familiar with what we are going to be talking here. Yes, couple no's. Again, like a 50-50 kind of thing here, I guess. Cool. Okay, practical Windows forensics. I built a course a while ago. You can take practical Windows forensics on demand on my website, also on other platforms. Same content, just with or without labs and things along those lines. But this is what we do in the course in the first part, right? We are going to set up a forensic workstation with all the tools we need in order to perform an investigation. And this is what we typically need to consider for the forensic analysis process. And I think this one is, kind of tells us the challenges that come with just conducting a decent forensic analysis process. So first, we need to be concerned about data acquisition, right? We talked about that a lot last week on last week's session. If you weren't part of last week's session, if you couldn't participate, please follow up. Feel free to follow up on the recordings. Those are in the email links that you get out, that you will be sending out later as well. Because data acquisition, there's a lot of consideration on whether it's in the cloud, physical systems, what kind of data we are looking for. But once we have successfully acquired the data, we need to process it, right? We need to extract information that we need. And that can be from different sources. That can be like from workstations and memory images, can be from disk images, Linux, Windows, Mac systems, can be logs from all kinds of different applications and firewalls and network traffic and whatever. We can also have the chance that we will come across malware. Actually, pretty certain we'll come across malware investigation. We need to know how to analyze that. And then also, finally, usually we perform timeline analysis to kind of have a chronological order of sequence of what happened, when, where, and how. There's tools that can do that. It can also be done manually after analyzing all the different types of artifacts. And then finally, there's reporting. And that is quite a lot, right? This is a pretty manual process. If you're working, if you just use basic tools, and if you don't have any kind of advanced environments or setups, every single one of these steps is a manual task, and actually probably quite a lot to do there with different types of tools. So there's quite a lot going on. And in order to tackle this, we'll talk about a few solutions here. Now, what do we need to consider when we are preparing ourselves for setting up a forensic workstation? There's no one-size-fits-all solution, but a few considerations that I think that are really important to keep in mind. So first of all, what is the goal, right? Do we want to set up a forensic workstation that allows us to triage and analyze disk images, memory images? Do we have a ton of logs that we might have to process? Are we able to, we also look into network captures and traffic? Or should we specifically be prepared to analyze malware? Different types of tools and requirements. And that is important because, and I would actually suggest setting up multiple different workstations for different purposes. But there's, already that like kind of data that we are working with is a good consideration that we need to keep in mind. And then secondly, what type of physical system do we need, or a virtual system? Do we want to host it in the cloud, or do we have a physical system? It might be really have a lot of resources and processing power, but there's pros and cons, right? With a physical system, it's harder to kind of wipe the environment after a case and start from fresh, clean again. With virtual systems, you purge the VM and you set up and you run a new one, and then you're ready for the next case. So virtualization is great if you have all the resources it needs. Then do we want to run Linux or Windows? That has a lot, not just something to do with our preferences, but also with the tools that we need and if they are compatible with Windows or Linux. And then do we want to go with a bunch of tools and scripts that we are familiar with, or do we want to purchase, or go for open source like forensic suits, like suits that actually have a bunch of stuff that they do for us automatically, versus us having to do a lot of manual labor. And then obviously there's a lot of commercial tools and expensive ones out there where you can do forensics with. We'll cover that shortly in a little bit. And there's also a ton of open source solutions out there. And as always, commercial versus open source will be a never-ending debate on what's better, what's not. For open source, you have the chance that things are probably not as robust and easily usable, but can go a long way. And with commercial tools, you just need a lot of money, and they are not always worth it the money either, but sometimes they are. And so just a lot of considerations here. Now, if you want to set up a forensic workstation quickly, there's a few solutions that we have out there. And so for this one, you can already see there is a pre-made forensic workstations ready to go. And I'm familiar with a bunch of those, but I wouldn't necessarily say one is better than the other. So first of all, there's, for example, the SIFT workstation that's been around for a long time. It's based on Linux, has a bunch of forensics tools on there, was started by SANS, and has a lot of good stuff on there if you want to get into Linux and performing forensics through a Linux workstation and all the tools that are there. It's already kind of a challenge, or like, a little harder to get into that, because you need to do a lot of manual tasks, such as even mounting an image in there on Linux is not that easy, and just clicking buttons in Windows, for example. There's the Flare VM. Flare VM has been created by SANS, and SANS actually has the, sorry, not SANS, Mandiant. And Mandiant actually has built a script that allows you to deploy all the tools that you need on a Windows system, but specifically for malware. So there's a lot of malware tools. It can help a lot with Windows forensics, for example, too, but those are malware focused. Same is true for Remnux. This is also by Lenny Seltzer, that's a SANS author. So you're basically using Remnux on the malware course for SANS, but it's Linux-based as well. And then even Kali has like a number of forensics tools that you can use for forensic investigations. I've used Kali before as well. Not purpose-made, but there's a good number of tools that can help there as well. So these are the VMs, the options that you can download for free. It's already out there, and it helps. But I prefer to build my own workstation. First of all, mostly on Windows, because a number of tools that I like to use are Windows-based, but also this is kind of the way how I get into the tools I became more familiar with. And this is a complete personal kind of decision, I guess. Some people are much more comfortable in the Linux environments. Some people want Windows environments. Some prefer one tool versus another that is not available on Windows or Linux. So even on Mac is actually a great trade-off between both worlds for some cases. But this is, for example, a list of what I would say is actually a decent setup for a forensic workstation. You can find this on the Blue Cape Security Build Your Forensic Workstation website. So these are free forensics tools, free in terms of you can download or test them, or for training purposes, free. Commercial licensing is sometimes a little different. You can find this list there of tools. And I'd say, when it comes to some of the different tasks, there is mounting. So Arsenal Image Mounter is amazing. It's awesome. It's actually the best tool to use for mounting images on a Windows environment. FTK Imager can do the same thing, as well as data collections in memory and disk images pretty well. Then there's forensic suites such as Autopsy. It's open source. It's a forensic suite that actually we will look into a little bit. So same as for Cape. Cape can help to collect data as well as parse forensic data. And then we have tools, individual tools for different purposes. So I like the Neursoft browser forensics tool because that quickly parses browsers artifacts for your web browsing history and stuff like that. And then when it comes to memory forensics, the one and only out there, Volatility, is a Python tool that you can use for analyzing memory. But there's also a tool called memproc.fs out there, which is pretty interesting, where you can mount a memory image and look into it. Also works on Windows, so that's why it's interesting. Then there's also on Windows, there's a ton of scripts and tools out there that most people, if you're in the field, have seen before. But Eric Zimmerman tools, of course, every Windows or most Windows artifacts that are out there and relevant for forensics, there's an Eric Zimmerman tool that you can use to parse it and then dump it into the output into a CSV or so, for example, to then create timelines and see what's interesting. Regripper to parse the registry and get some information out of it. Based on the plugins, you will get your visibility and data out of the registry. Not everything is covered that is part of a registry, so be careful. And as always, with any tool, basically be careful and understand what the tool is doing. You might still miss certain areas. And then for malware, PE Studio is awesome. It lets you analyze binaries pretty quickly. Of course, decoding, encoding, or decrypting malware or payloads using CyberChef. Shellcode debug is a great tool for that as well. And timelining is Plazolog to Timeline, which is a Python-based tool. So just a list of some of my tools that my go-to tools that I would use on a daily basis. And those are also, some of them are Windows, some are Linux-based. So I need to switch between different types of environments. Unless you have taken the Windows Forensics course and have started creating your own Windows Forensics workstation, because what you can do nowadays in Windows, which is awesome, is Windows subsystem for Linux. So what you have here is all the forensics tools on Windows. And then you also have the option to install Ubuntu or Linux on a Windows system, run it and install Log to Timeline, install Volatility. And then you're basically all set with the best of both worlds. So really an interesting, option there. It doesn't work so easily in the cloud. In Azure, you can do that. In AWS, not so much. But this is something that I definitely like because we have the best of both worlds. Now, we covered a few tools, and I'm going quickly because we already have way too much to look into and in terms of content and a few demos. So Cape, people in forensics world are probably familiar with it. Autopsy, you might have heard about it too. Just wanted to show you just real quick on what we can do with Cape, for example. Now, that Cape has come up before a lot because of the data collection options, right? Cape can be run in the command line terminal or can be run as a graphical interface like here. So this is the graphical version of Cape. And the cool part about it, we have covered the data collection part, is where you can basically point it to a source, and then you can have it extract the artifacts that you want based on what you select down here, right? You can select every single Windows artifact that you can think of. You can also add your own parsers to this, or you can say, basically collect all of them as a compound package, which means a bunch of the most important ones are actually part of this collection. And if we click execute, it would then grab all the Windows artifacts and put it into the triage folder here. And that's a quick and easy win. We've talked about the data collection last week, so I'm going a little faster here, because what I also wanted to show you in this case is that what I like a lot is this part, often overlooked, but once you have extracted the data, we can apply parsers at scale quickly and easily too. So for example, now after we have collected the data into the triage into the triage folder. So you can see that here, triage, the output looks something like this. There's the logs from Cape, and then there's my drive. And on that drive, in my Windows forensic image, I basically extracted these files or these folders from it because those are forensically relevant. And we still maintain the disk structure, or the file system structure, I should say. So we have the MFT, which is an important artifact. We have a number of Windows folders for users, as well as Windows folders itself. And in those Windows folders, as the forensic experts here know, there is Windows event logs in some of those. And then there's also the registry keys, Hives in raw format. That's great, right? But we can't read that, so we need to process it. And so this is where this comes in handy. You can do it manually one by one with a tool, or you can use this kind of feature here in Cape, where you can run the source. You can point it to the source, which we just extracted, and then say, run this particular tool. It's mostly, it comes with the Eric Zimmerman parsers. You can add additional parsers, but if we just say run all the Eric Zimmerman parsers against this source, then we get an output. And I just did that right before this session today. That is in here. And it basically puts it into different categories. So here's the output. And so just by running this setting up here that you can see here, all the Eric Zimmerman parsers, we get a bucket for event logs. And now we have all the event log information in one CSV. Then we get a category for, which ones are interesting? File folder access. Those who are familiar with forensics know that there's shim cache, and there's other kind of linked files and things along those lines that can basically help us to identify user behavior. And so there is output right there. We can also see file system. There's the classic MFT output, a few other ones. So here's all the MFT information that we might be looking into. And program execution, one of the most interesting ones. We have mcache data. We have shim cache, app combat cache right here, shim cache data. We have prefetch file information here as well. So within program execution, there's a number of these artifacts that we can then dump into Excel or the Eric Zimmerman timeline viewer, and then just analyze it. And so on. Same for registry. There's information extracted and a couple other artifacts. So won't look too closely into this just yet, because we have a few more things in the works, in the plan here. But this is a quick way where you can collect the data and then just click on, hey, analyze, or apply all the Eric Zimmerman parsers, and then you get this output. Helps already, kind of, come getting along. So let me know if you have been, if you knew that, or if this is something you've been using, or if this is, something new, or if this could be helpful to you, because I think this part, the right-hand side of Cape, is underrated, but can help us get a long way. If anyone is using it, new and helpful, awesome. Okay, great. So we already have a first win. Somebody learned something new and finds it helpful. I like that. Cool. Okay, so we have one more demo. We can then look into autopsy, because just real quick, if you don't want to apply the parsers manually into, for every single artifact, there's suits. There's like, commercial ones, and there's free ones you can use to point to the disk image, for example, and then it extracts all the data for you automatically at scale. Now, the disadvantage with that is this, for example, I did that 2 days ago, and I think it ran for like 24 hours, at least 12 hours. And at some point, I think I canceled. So somewhere between 12 and 24 hours, I canceled it out. After the first few minutes, you're getting the most important information anyways, but it can be helpful to get things going and parsing while we are basically doing other things, right? So if you have time, great. But I'd say, many times we are part of like, live fire kind of, event where we need to act quickly. And so we don't have time to sit overnight and wait for a forensic suit to basically parse our images. But it can still nevertheless be helpful for in-depth forensic analysis. So this is what I did for our disk image. I basically parsed it through Autopsy, which is a free tool. And then you basically get, all the handy information right here, the type of operating system, user path, folders, and so on. And then from there, it would, you get file views. You can look into different types of files that were found, deleted files. A bunch of them are actually been at least noted here, different types of files based on sizes. and then the analysis results and data artifacts. So we can get a number of information in terms of installed programs that was retrieved from the source, such as the software registry Hive. We have metadata. I don't know where this is technically really coming from, but seems to be telling us a lot about the different types of documents that were open and files. Then operating system information, we just saw that. And then recent documents, right? So this is basically something where we have the most recent artifacts basically parsed for the particular users and can see what this user just was accessing. So lots of link files, it seems like, where this is coming from. Somebody, this user here, means that they were opening the directory PWF main on their desktop. So that's evidence of user behavior, basically, that they were accessing this particular location. Same for shellbacks. Shellbacks is evidence of what users might have opened in the browser, in the file browser. So you can see here, user class, the registry Hive for this user basically shows us that they were in PWF main and install sysmon and run atomic red team. Also, they access the file share on our VirtualBox server, which is basically our host system. So that's where they looked into it. And programs that were executed by a number of sources, we can see .pwf. So those are the prefetch information that we got. I think there's also a couple other, yeah, there we go, resource monitor, and from the backgrounds, we basically get execution of different types of programs here. So that's quick and easy win to go through these. There's also some web browsing and web artifacts that we can see. I'm just going quickly here, but it basically helps us to, don't have to do all these things manually, and then you can search for it. And one cool thing, there's a view where you can actually sort everything by timelines. So basically you can say, give me information by events in terms of times. So we have a time frame here. We can have a list of all the different events that happen within that time based on the timestamps. We can also parse this out into different types of views, such as give me the details of what happened when in a chronological order. Can't go too far into this now because of time again, but play around with this if you have an image and if you have this type of application. If you want to look into closer into Sleuthkit autopsy, highly recommend, because it can actually help, and it's actually important. It's very informative in terms of training too. You might find things that you might have not been aware of before. So much for autopsy or CAPE. If you have questions, please put it into the Q&A, and then I'll get to this at the end of the session. All right, I like, thanks for providing some of the information in the chat. That's great. Again, for questions, keep it in the Q&A, but I like the discussion going on for sure. So feel free to continue as I am jumping into the next one here, which is enterprise DFIR tools. We talked about forensic workstations, free tools, open source tools, things that you can do quickly and easily. And to be honest, I've actually used all these tools I just covered earlier in my professional environment. So I have actually been using mostly Eric Zimmerman tools in all kinds of shapes and forms, and automated them in a way that was helpful to make my forensic analysis workflow easier. But there's enterprise DFIR tools. And so what we need to know, for people that work in the field are pretty much familiar with this, but what you see in an enterprise security operating center is a few very, very important common applications. And this is basically the SOC visibility triad. So we have, as always, we have had a SIM, right? SIM is basically where we are getting the logs in, and where we have user behavior analysis, and we basically just go through everything that is happening. That's been around for a very long time. It's collecting all the alerts, all the events, all the logs, and that's where we usually, and as a SOC analyst, are looking into for the better part of the day usually. There's also then getting more visibility into anything that happens on endpoints, and this is where EDRs, endpoint detection response applications, have picked up, right? So you get visibility into anything, any activity, any event that you would not see just by looking into logs that are coming out of an endpoint. So that is actually, the new hot kind of, not new, but the hot kind of tool out there these days, where it's pretty expensive, but it can go a long way because it automatically in real time detects and prevents a lot of things, throws alerts, helps us to respond, triage that kind of information. So it's been around for a while. And but also that is then being complemented by visibility that, through NDR that gets us visibility into the network environment. So same concept as EDR, but just NDR in this case. NDRs, there's a bunch of commercial solutions out there these days, which are pretty good in looking into network traffic and looking for anything suspicious, malicious activity, alerting, preventing, things along those lines. But then combining all of these applications and solutions and making sense of all the type of data that is in there is nowadays being called XDR. So that's the extended detection and response solutions. Now, if you have all these three, if you have the triad and then have visibility into all three of them and maybe a tool that can analyze data and correlate data from all three of them, that's what we call XDR these days. And that's all, of course, in the commercial enterprise environments these days. Now, a few of those things that we want to train up on and we want to get better at, you can do on your own labs, for example, because there's free solutions out there for SIMs and EDRs and ways of how you can do that. But, and of course, more manual and not as fancy as it is, you can get it from a commercial kind of product. And then also what you can do as a forensic analyst in an enterprise environment is enterprise DFIR tools. Now they use, there's tools such as forensics tools such as Autopsy, and then the commercial version of that, for example, a similar one is Ncase or Xways, things along those lines that can make your forensics easier based on a dead disk forensics. But if you need to look into live running hosts, we have solutions such as Cyber Triage out there. Binalyze is a new one that's out there. You can use those for in a trial basis, but the cool part about those is that you can pull the data through agents from those systems, and then the tool would, just like Autopsy did, basically parse it out for you, looking into the different artifacts and then showing you, bad items, suspicious items. Same thing for Binalyze, so you can get the same kind of information based on what's going on in your endpoints. So kind of forensics, remote forensics on live systems, pulling the data into your environment. Now, those are, you can use them for in a trial basis and test them. But there's also another tool which I would wish we'd had more time and look into and get closer and take a closer look at, Velociraptor. So who here is familiar with Velociraptor or is even using it in production environments? Just curious, because Velociraptor is an awesome tool. Yes, some people, lots of yeses actually. So some heard the name. It's awesome because this allows you to install agents on endpoints, and it is a single pane of glass where you can basically, like you can see here, have a list of systems, and you can apply. It's not as much. It can do real-time detection and response, but it's a lot, and it goes a long way when it comes to performing forensics at scale. So, for example, we can select our hosts here, and we can apply those Eric Zimmerman tools that we would manually do on a disk. We can apply those on a running system and pull back the data across all the different, many systems, actually thousands of systems. It scales really well, and get the data back into a Velociraptor server view and then analyze it from there. And again, don't have a demo for this today, again, because it would be a time-consuming one, but we cover this in a lot of courses because this is something where, it just gets you the idea of an EDR, but also you can do a lot of forensics that you can't really do as much on an EDR. You can run your own tools and you can collect data at scale. And that's a very, very important part. You can run CAPE triage packages, such as what you've seen earlier, through Velociraptor to collect the data from different systems and then analyze them, download them and take them offline. So really cool solution, should be part of every lab. On my Blue Cape Security website, you can actually find tutorials on how to set up Splunk as a SIM and Velociraptor as a EDR IR tool. And then now we're going to get into advanced solutions, automate and scale. And I think this is always pretty eye-opening because now you get to see what's possible based on the basics we just covered. We talked about this forensic analysis process, right? There's a lot of steps involved, a bunch of them manual steps, starting with identification of the data, acquiring the data when it comes to many systems, that's tricky, processing all the data across the different artifacts, and then we can then finally perform analysis in some shape or form. And that can take a long time, right? It's can take many hours or sometimes even days per system to look into this. So the question now is, how can we automate and scale this? Now, we've talked about some, those commercial forensic solutions before. They can be helpful. Certainly, they can do some of these things. But based on the tools we've discussed, there is a few ways we can do that. Now, thinking about this streamlined forensics workflow, we need to think about how can we remotely collect the data that we need. Speaking of Velociraptor, how can we process automatically the data, and how can we then populate the data for analysis? And this is, for example, here in the environment, we have like 4 hosts out of 1,000 or so, or maybe 40 hosts out of 1,000 that we want to collect the data, assuming, if this is a ransomware case, I would say there's probably a dozen or so compromised systems. We don't know which one is like, hot systems, which are the critical systems, which are the important ones, which ones were the ones where they got initial access to, and then moved from there. So we have, maybe we have like a dozen or so suspicious systems. We need to pull the data offline so that we can analyze it. And the way how we can do that is through a process, something like this. So for the remote data acquisition, we can use something like Velociraptor and the CAPE files, the CAPE targets called, to get the data collection from the endpoints that we select to our server. Now, those can automatically be uploaded to a cloud storage, for example, and that's where some automation can trigger, which can then automatically start parsing the artifacts, the data that we collected. And then once we have parsed it in something such as a CSV, for example, or so on, or in some other kind of shape or form, a file that we can then use and push it to a tool where we can then analyze the data. And the analysis can be done in, you can push it into Splunk because that works pretty well to query for events and correlate events and things along those lines. Or one of those tools that really work well for forensics is called TimeSketch. So another question, TimeSketch. Has anyone seen or used it before? Because I feel like this is one of the less popular or less well-known ones, but even better because it's amazing, and we're gonna look into this. So yes, knows, new, seen it before, not. If you type, make sure you type to everyone. Otherwise, it's just me, so you can see it. There's lots of no's, and that's awesome. Something new. So this illustration is, we can see the source here, but really where this kind of idea, so I've been using this in our previous, consulting organization, cloud environment, where we kind of had the clients upload all the data they collected, and we automatically processed it. So that at the end of the day, a few hours later, all I had to do as an analyst was getting into my tool, my TimeSketch tool or Splunk tool, to analyze the data that was automatically processed a couple hours before. That's the goal. We don't want to do much. We just select and we wait for a few hours to have the data ready. And that's something that is, very well documented by Recon InfoSec for people who know. Eric and Whitney, those are pretty open about the open source solutions and really awesome solutions that they post on GitHub all the time. So you can find it there. They also have talks about this, but this illustration came from a different resource, but I just like because it's, really clean and it gets the point across. But the idea is always the same. We collect, we process, and we analyze. And this is Eric, and he now works for Lima Charlie, which is also an amazing tool. It's security operation cloud platform. So it has a lot of real-time alerting and everything, but also what he can do is collecting and analyzing and dumping the data into different storages for the analysis. So you can also use Lima Charlie, for example, to collect the endpoint data and then have different work streams kick off, right? You have like tools such as Hayabusa that can, for example, parse the event logs and alert for threat detections. You can also have what we just talked about, a tool such as Plaso, and then create timelines with it and analyze it from there. So they have various resources out there as well. And I used to do that as well in our forensic lab environment. And that's what I'm wanted to show you for a few minutes here before we're running out of time on what this is all about. So TimeSketch, for that, we need to process the data. Processing data can be done through different forensics tools. One of them is Plaso and Log to Timeline. So anyone familiar with Plaso and Log to Timeline? No, okay. Yes. No, so basically those who have taken the practical business forensics course have probably seen it before because we covered in my forensics course. But if not, log to timeline is basically a tool, it's a suite of tools. It's called Plaso, and it consists of log to timeline, pf-info, pf-sort. So basically, log to timeline allows us to parse a disk image, apply a ton of parsers on it, and output into a storage file. And the storage file can then be used and then we can put it into a CSV or upload it into a ELK stack, for example, for analysis and things along those lines. So it all starts with log to timeline. And if we just do, I think it's info. Yeah, if we just do info, this shows us all the different parsers that we could be applying, that we can apply against a image. So as you can see, it's quite a lot, right? Let's just start from the top. Actually, let's pipe this through this. Might be a little easier. Okay, so log to timeline, you can apply it against the disk image or multiple different data formats, and then you can apply, parsers such as it has Android parsers, Chrome browser parsers, iOS, Mac, all kinds of stuff, and of course all the important ones for Windows, such as prefetch for Windows, recycle bin for Windows, event log for Windows, and all kinds of registry locations for Windows. So all these things can be applied at once. So you can just say apply all the parsers you can apply against what we have, or you can say particularly just apply a few parsers that we want against the data that we're dealing with here right now. And so at the end of the day, the output might be based on something like this, a Plaso file. This is the storage container. And so if we use the second tool part of the Plaso suite, which is pf-info, and then just point it to the timelines storage file, we can now see information, metadata about this Plaso file and what it contains. So aside of some of the warnings, we can now see that Plaso version, and then we got 160,000 event sources. And here we can see the number of, oops, too fast. It's a little tricky here in Linux to scroll. Events generated per parser. And this is really cool, right? So basically we pointed it against the Windows disk image and we got 190 Mcache entries out of it. We got 300 Shimcache entries. Back MRU, we got background application moderator artifacts, mount points, NTFS information, link file information, all kinds of interesting stuff, as well as event logs. So we got 64,000 events from the event logs. Got some Win logon events. So these are all the parsers that were successfully applied. So altogether, we ended up with 1.5 million events that are stored in this Plaso file. So now you can dump this file and into a CSV, or we can upload it into a tool that allows us to analyze it. And one of them is TimeSketch. So TimeSketch looks like this. You might be familiar with ELK or Elasticsearch. So basically Kibana interface, same kind of idea. It actually is a fork of Elastic. And so to remain it open source, because Elastic, had some license changes, but Google actually owns this project, forked Elastic and created OpenSearch. And OpenSearch, basically, then one of the variants here is that they created was TimeSketch, which is an open source tool specifically for forensic timeline analysis in a collaborative way. So multiple people can look into the data sources here, the events, mark them, collaborate, can add comments to it and things along those lines. And for a few minutes here, just real quick, I wanted to show you, because it's so awesome, how to go about this. And so here's TimeSketch. This is actually the Linux system we just were in, so just accessing it through the browser. And then you can upload basically your investigations. So I uploaded this particular Plaso file straight from the Plaso tool into TimeSketch. And when we open it up, we can already see, refresh real quick. There is kind of the overview of that you're used to with Elastic or with Splunk. You have search queries you can enter here. And then after search queries, you can see a timeline and you can see the artifacts we want to apply it across a disk. And then we can see results. So the syntax is a little different than what you're used to usually. There's different ways of the query language that it takes to get things done. But here is my search history. It's actually a pretty nice overview. You can actually see what I applied, when, where, and how. And I have also saved searches, which you can see here. There's just one saved search. And this is basically saying, show me everything between a particular timestamp. So I have timestamp from, between, there's like a timestamp of 1 minute on the March 18th. Do not show me any NTFS information or user journal information because there's a lot. And then basically all I'm left with is Windows event logs and records. So there's a lot of Windows event and logs. At some point, we see some web cache, and this is the part of the super timeline creation, right? We have mixed outputs from different artifacts. We have event logs, we have registry information, we have file timestamp information, we have all kinds of cool stuff that is all basically lined up in a timeline. And what you can do here, so I just enabled USN, so the USN journal, which keeps track of file changes and stuff like that. So you can go through this, and when you find something, so for example here, Windows Defender security product stays new, so Windows Defender was disabled, you can highlight it, you can label it, you can add comments to it, you can open it, you can see all the information about the particular event, and this is purposely made just for forensic analysis. And so there's, when you add labels to this, there's a few more things that you can look into. So for example, or tags, it's called, show me all my starred events. And then I need to remove this one probably. So now I'm ending up with just my labeled or starred events, where one of them I say, hey, in the Windows registry, there's something bad. In the Windows registry, I also found something suspicious. So if I open this up, one of the things I found through my analysis was that there is a key called Atomic Red Team and a folder, a path. Then there's a key called ART. And then in this key, I found a payload that is base64 encoded. And that's suspicious because this is what I'm looking for. I know there's something that, something based on the Atomic Red Team happened here. So I tagged it as bad. And eventually, you can collaborate with people across this and then basically report all the findings, tag them, and put comments on it, and then download them, report on them, and so on. So really cool tool to just basically get your investigation analysis going. And it has a bunch of features that you can use to automate it. So for example, it has graphs. It can automatically show, graphs such as who installed which service. So there's a malicious service right here that was automatically kind of, found by the tool, by the plugins that are there. And a lot of more things. You can apply threat intelligence. You can apply Sigma rules, analyzer results. I just ran an analyzer thing yesterday to show me all the domains that you were able to find across the entire data set. And it found a few rare domains, a few known CDNs, a few regular domains. So if I just do rare domains, here I have labels on all these events because somewhere in this particular payload, there is a mention of a domain that I probably want to be familiar, wouldn't have seen otherwise. And so if I go into the payload, I guess there's the domain that it found. And it was identified as a rare domain because apparently it doesn't show up too much, but basically have a domain parser right there. Same you can do for accounts, for other, and all kinds of other stuff. So this is one of the tools that are really cool for analysis. I wish you had more time to run more queries, but the search queries are a little tricky. And in order to make that easier, there is a resource, and I'm going to share the links with you in a little bit, by somebody who is just awesome because they put queries into GitHub on how to use TimeSketch and run those queries on the different data types that we have. So for example, if I want to look for Windows events and 4624 logons and logon type 3, those are the queries that I need. And I don't even know if this one is going to work, but guess not, because I missed thing here. I think Copy paste issues, of course. There you go. I have another one prepared here, which should work. See if this one works, but basically you get the idea, right? So we were looking for a data type, in this case, registry key, and look for a timestamp where we have content modification time, where the content was modified between in a particular timestamp. And then I'm also just interested in anything in this registry key that mentions the word atomic, because this was my test script, right? So now I have a lot of outcomes, but if I add a time filter where I'm only interested in events that happened when this disk image was created, at least attacked, let's put it this way, I'm gonna just do add the filter. And so look at that. I just found registry key entries with this particular term during that time frame, where one of them was actually the malicious one we had earlier. There's another one which might be a false positive. And then there's a different one that I marked as suspicious because I'm not sure where this actually came from, but it has something to do also with atomicservice.exe, which is a malicious file in this scenario. So the query language is a little challenging. Every tool is a little different, but this is open search. So you can also look this one up over here. I'm going to post follow up with the links in a little bit, but hopefully somebody or people find this really helpful, because it's something that doesn't get talked too much about out there, but can make your life easier, especially when you want to collaborate on that. And finally, that's the forensic, the streamlined process, all the way from collecting the data, processing automatically, picking it up by Plazo and block the timeline, which hopefully everybody's now familiar with, then can automatically be pushed into time sketch, which we now just analyzed here, right? So as an analyst, I go in Velociraptor and collect and selected the systems I want to collect from. And a few hours later, hopefully I can just come back and look at the data in time sketch. And if for the hardcore, advanced version of people that want to automate workflows in cloud environments, for example, such as AWS, there's a great resource by AWS. They actually have really good articles about DFIR as well. There is a proposal on automated forensics orchestrator for Amazon EC2 instances, right? So if you have a VM in Amazon and the VM might be compromised in your own environment, you can trigger an automatic workflow. So this is the application account. This is the compromised instance. The workflow might send a notification. It might trigger the triage flow to basically triage the system, to lock it down with a security group, to acquire the system's information, such as the memory and disk images, and then send a notification and put the data into S3 buckets and so on. And then you can process it basically, or start even the instance in your own secure environment to analyze it. So this is the advanced version of what you could do in a cloud environment, automating everything, every single step along the way to make your life, once it's running, easier.